Welcome to Section 9.8, Pythagorean's Theorem in Space Figures. Our objective is to apply Pythagorean's theorem to solids. For homework, we're going to be working on page 415 to 417, 3 to 6, 8, and 13 to 15. So we have a lot of vocab that goes with this section. First, a prism is a solid with two bases. A pyramid is a solid with one base. And when I refer to the solid, I mean a three-dimensional object. Second, the polygon of both are referred to as faces. The segments that make the sides are called edges. In a prism, the imaginary line connecting opposite corners of the prism are called diagonals. The meeting point of a pyramid is called the vertex. The height of the pyramid is called the altitude. And the perpendicular segment on the side of the pyramid is called the slant height. This is the vocab that we need to know for this section. So we get to our first example. If the dimensions of a rectangular solid are 3, 5, and 7, find the diagonal. So here we go. We're going to start off building a rectangular solid. So if you haven't done this before, here we go. First thing that we want to do is we want to make a rectangle. From that rectangle, starting above and towards the middle-ish, you want to make a rectangle using a dotted left side, a dotted bottom, a solid top, and a solid right side. Connect the top left to the top left with a solid line, bottom left to bottom left with a dotted, bottom right to bottom right with a dotted, and top right to top right with a solid. The dimensions of the rectangular solid are 3, 5, and 7. It doesn't matter what you call one. One of them needs to be my length, so I'll call this side right here my 7. The other piece has to be my width. I'll call this piece 5. And the last piece needs to be my height. I'll call that 3. You can mix them up in any order, but those are the pieces that we need. Now, if we want to find out what the diagonal is, here's what our diagonal looks like. It's going to connect opposite corners, and it cuts through our prism. Now, what we have to do is we have to build right triangles. Now, in a rectangular solid, all of my corners are rectangles, so have right angles. So here we go. In order to make this right triangle, we have a horizontal line here, a vertical line here, hitting a horizontal plane on the bottom. So when I draw in a diagonal of my bottom, a right angle is going to be formed here. The problem is I need to know the length of that side. What I have here on the bottom here is a rectangle, and I'm going to pull that out. My sides were 7 and 5. I need to find the length of that diagonal. Opposite sides are congruent, so there's my other 5. I'm going to use Pythagorean's theorem. 7 squared plus 5 squared equals x squared, because we knew it was a rectangle and we had a right angle at the corner. 49 plus 25 equals x squared. 74 equals x squared. And we can square root that, but we don't need to simplify it. The side right here is the square root of 74. In case you didn't hear, my big girl is here with me. Say hi, Paige.
Hi, Paige.
Don't say hi, Paige. Say hi, kids.
Hi, kids.
Alright, we're going to keep going here. Now, since we have a rectangular solid, opposite sides are congruent, so if this is 3, so is this. And now we're going to find out what the diagonal of my solid is. Paige, what theorem should we apply?
Pythagorean theorem.
Pretty close. Pythagorean theorem. That's a big word. So here we go. 3 squared plus the square root of 74 squared equals x squared. Paige, what's 3 squared?
9.
Beautiful. And the square root of 74 squared?
74.
Equals x squared. Add that up and we end up with 83 equals x squared. Square root both and try and simplify. Does this simplify, Paige?
No.
That leaves us with x equals the square root of 83, and we're done. Alright, it's time for bedtime for real. So Paige, say goodnight, everyone.
Good night, everyone.
So for our next example, We're given the square pyramid shown with an altitude PR and a slant height PS. Perimeter of MIDA is 40, PA is 13. We want to find ID, PS, and PR. So the first thing is if we have a square pyramid, what that's going to let us know is that the base is a square. So if the perimeter is 40, that means that each full side is going to be 10. Now, we see S here. Where the slant height hits is going to be in the middle, so it's going to split this side up into 5 and 5. They also told us that PA is 13. First thing they want us to do is find ID, which we did by looking at the perimeter. ID is 10. Next thing they want to know is they want to know what PS is. So I'm going to put an X right here. Well, let's think about this. When we talked about what it meant to be a slant height is actually going to be perpendicular. So when I actually take out that side triangle here, if they give us that one edge is 13 and PA is considered to be an edge of our pyramid, it means that it has two of the same edges, making a nice isosceles triangle. And when we have the slant height, it's going to be perpendicular to the base, which splits it in half. So let's solve for what PS is going to be, using Pythagorean's theorem. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. So x squared equals 144, making x 12 when I square root. So we have x is 12, which is our PS. Last but not least, we want to find out what PR is. So I'm going to call that y. Y goes from the top, and it's going to hit the dead center of our base. Now, if it's hitting the dead center, it's going to go all the way down, halfway up, and halfway over. So our S is also going to be 5. That always happens with a pyramid. It always hits in the middle or the halfway point for all of the distances. Now, when I pull out that triangle in the middle that had those dotted lines, and a solid side, that solid side right there was my slant height, which was 12. And we had a piece 5. We're trying to solve for y, so Pythagorean theorem it again. Y squared plus 5 squared equals 12 squared. Y squared plus 25 equals 144. Subtract 25 to both sides. And y squared equals 119. Square root that and simplify. Nothing divides in evenly to give us 119. So y is going to stand at being the square root of 119, which is what my PR segment is. Now, my last example is very, very random. This was kind of thrown into the section, and I really don't know why, but we're going to go through it. We're going to try and find the measure of angle AYB. Now, it's definitely not a central angle because its vertex is not at the center, nor is it an inscribed angle, as its vertex is not on the circle. Its vertex goes beyond the circle. And whenever we have an angle like that, this thing is actually called a secant-secant angle. Secant-secant angles get discussed a lot more in Chapter 10, but here's how we solve for those. I'm going to call that angle right here x. A secant-secant angle intercepts two arcs, a 120 arc, which is AB, and a 40 arc, which is down here. The way to find the measure of a secant-secant angle is to take 1/2 the difference of those angles. So 1/2 of 80 gives me a 40-degree angle. And that's how you would solve for that. So here's our answers to the homework. Again, we had 3 through 6, 8, and 13 to 15. If you have any questions, make sure we ask them tomorrow. And as always, have a good one.